absurd. You're a hero, and you look great.
Hello guys, welcome to the new video, Wizard Concepts of Mathematics. So I think so this will be the last video of quadratic equations. So all the vital concepts which are the unknown concepts, like which are not actually mentioned in many of the books, as well as many of the mathematic resources. So these are all the things which are derived from the derived things. So this makes the maths easy, like solving math problems easy. So Wizard Concepts of Mathematics is primarily for Olympiad students or any other competitive exam students, because these are all the concepts where the actual competition arises, because these are all the concepts are not studied by many people, because this is it's a derived thing, like it need to be specially derived and need to be discussed. So that's not done in various colleges or various books or something like that. So this playlist is primarily for those students who are aiming for mathematical exams and all. So let us start today's video, Wizard Concepts of Mathematics, quadratic equation. I mean the last video, I think. So this is the concept. So the concept is reciprocal equation of the standard form can be reduced to an equation of half of its degree. Okay, what do I mean by that? So I'll just take an example and illustrate that. So if I take an equation, so if I take an equation in this way, ax power 2m plus bx power 2m minus 1. So it started with 2m plus cx power 2m minus 2 plus so on plus cx square plus bx plus a is equal to 0. If you observe that c is the coefficient of x power 2 m minus 2 as well as x square, and when you add them it reminds to like it equals to x power 2m, isn't it? It's x power 2m minus 2 and x square. So it's actually the total degree which is it's consisting of is x power 2m. You cannot just add it, but I'm just telling you, okay? And yeah, for the first term and the last term again it's x power 2m, like the sum of all the degrees, it just equally to which is getting equal to x power 2m. So again b in the same case, here x power 2m minus 1, here x, so totally x power 2m. So actually this is the way you need to get an equation. Now just divide by x power m, okay? Just divide by x power n both sides, so you would get it in this way: ax power m plus bx power 2m minus 1 minus m, which is nothing but m minus 1. So this goes on cx m minus 2 plus so on plus c by x power m minus 2, because this is x square here, and when you divide by m it becomes m minus 2, plus b by x power m minus 1 plus a by x power m is equal to 0. Now you can just take that in this way, like you have a into x power m coefficient, like a into x power m here and a by 1 x power m here, b into x power m minus 1 and b by x power m minus 1, the same degree of x, but it's in the denominator here and it's a numerator here. So you can just take the things common and you can solve for so you can solve further. So you can write it in this way: a into x power m by 1 by x power m plus b of x power m minus 1 plus 1 by x power m minus 1 plus c of x power m minus 2 plus b of x, like 1 by x power m minus 2 plus so on. So this goes on, isn't it? So this goes on, and there will be some constant which has no degree basically, and let it be x k is equal to 0. Like it is not a coefficient of any x, like it's a constant in somewhere around middle, you can find that, and let us assume that to be k, and this is all nothing but 0. So getting into the next page, so this is nothing but, now I wanted to write a tell you people a generalized thing, that x power p plus 1 plus 1 by x power p plus 1 is nothing but x power p plus 1 by x power p into x plus 1 by x minus x power p minus 1 plus 1 by x power p minus 1. isn't it? Because x power p into x is x power p plus 1, we have got one term, and x power p into 1 by x is nothing but x power p minus 1. So I need to cancel that, so I just need to subtract that here, and x power 1 by x power p into x, again I'm getting an extra term that I need to cancel here, and 1 by x power p into 1 by x, which is 1 by x power p plus 1, that I've got here. So this is how we can just represent an ideal situation which is in x. So in this is the same way I can even write for this, right? So if I assume p to be 1, then I get x square plus 1 by x square is nothing but x square minus 2, isn't it? You can just like, it's not x square minus 2. If I just assume that, okay, if I just assume that z is something like, or if you can just put it here, it's basically x plus 1 by x into I just put like p is equal to 1, so I just put p is equal to 1 here, into x plus 1 by x, isn't it? This is how I can write, and minus of x plus 1 by x, I have just put p here, so I get 2. So if I assume x plus 1 by x to be z, so it's nothing but z square minus 2, isn't it? This is what I'm gonna get. So what if I take p to be 2, then it becomes x cube plus 1 by x cube, which is nothing but z into z square minus 2 minus z. You can just solve it, you can even see that. So it becomes z cube minus 3z. So here it is z square minus 2, here it's z cube minus 3z. I hope you can get a further idea, like x power 4 plus 1 by x power 4 is nothing but z of z cube minus 3z minus 3, like it would be, yeah, minus of z square minus 2. So this is what it's gonna be. So it's nothing but z power 4 minus 4z square plus 2. So this is what we're gonna get. So it's just like, you can see a pattern here, minus 2 here, minus 3z here, minus 4z square here, like you can get an idea of the pattern being following, and the other constant you can just solve it and you can get it. So we can write that in this way, and in the same way you can just proceed actually. Yeah, so this is how you can just put a values, like for x square plus 1 by x square, you can just put it in this way. That is nothing but x plus 1 by x. 2 for the reduction of writing space, I've written in this way, but there's nothing else. You can just put that value and you can even do that in that way. So it's like reducing the space area of solving, so that it gets idea, like the final result that we're gonna get will be in the easy format. So this is how we need to do it. So general thing is x power m plus, like the general thing that I wanted to tell you is x power m plus 1 by x power m is of m dimension, is of, or you may say is of m degree, okay, or either I would say m dimension only, because it's not an m degree, because you can see one, it's in the reciprocal to z, okay, it's in the m dimension to z, and therefore the equation in z is of m dimension. So the thing is, we have got an equation in the power of m plus 1 by x power m, like it's x power m plus 1 by x power m. So it's basically, you have made that into z, which is also in the dimensions of m. So this is how you need to tackle this problem. So coming to an example, it becomes easier for us. So this is a biquadratic equation, and the thing that you people need to notice is the coefficient of x power 4 and the constant, like the coefficient of x power 4 is 2 and the constant is 2, and coefficient of x cube is 1 and the coefficient of x is 1. So 3 plus 1 is 4. So both the coefficients, like the degree, the original degree of this biquadratic equation is 4, because it's biquadratic, it's obviously 4. So you need to make sure that the terms which are like the degree which are adding up, their coefficients it's the same or not, like x cube and x. So it's 3 here, it's 1 here, when you add them you're getting 4. So you need to make sure the coefficient are the same, and here x power 4 and your constant, which is nothing but x power 0, when you add them you get original degree 4. So you need to make sure the coefficients are the same, here 2 and here 2, so they are the same. And this is we have no like it's not even linked to this, so it's as a minus 11x square. So how come we can solve this? Is the same thing, just divide by x square on both sides, because it's m is 4 here, okay, m is 4 here. So the thing is, you can just check here what we have taken. Yeah, sorry, 2m is 4. Yeah, 2m is 4. Yeah, 2m is 4, so m is nothing but 2. So just divide by x square on both sides. So it becomes 2x square plus x, yeah, it's minus here, minus 11 plus 1 by x plus 2 by x square is equal to 0. Now you can just take the common, like 2 of x square plus 1 by x square, and if you take this one, like you can just take plus 1 common, you get x plus 1 by x, and this is minus 11 is equal to 0. So now x square plus 1 by x square, you can just write it in the form of x plus 1 by x. It is nothing but x plus 1 by x whole square minus 2, isn't it? Because x plus 1 by x whole square is x square plus 1 by x square plus 2, plus 2 minus 2 gets cancelled, and here x plus 1 by x is already there. So you can just assume that x plus 1 by x has some y, so it becomes y square minus 2. I'm not taking to be z because you people might get confused with the previous thing. I'm just using the different terms possible. So it becomes 2 of y square minus 2 plus y minus 11 is equal to 0, isn't it? This is what my equation will be. So it's basically 2y square plus y minus 4 and minus 11, which is equal to minus 15, is equal to 0. So I've converted my biquadratic equation into a quadratic equation. Like the properties differ, but the like solving it becomes easier for us. So like to proceed further for solving the biquadratic equation, so when you solve this biquadratic equation, like this one, the quadratic equation, you get y values to be, one value is minus 3 and the other value is for y by 2. You can just solve it and you can check for that. So y value is 1 by 3 and another is 5 by 2. So it's basically x plus 1 by x is equal to minus 3, and here x plus 1 by x is equal to 5 by 2, isn't it? This is what the value are. So when you solve for them, we get that x1 to be minus 3 minus root 5 by 2, and the other value x2 is minus 3 plus root 5 by 2, and x3 is 1 by 2, and x power 4 x4 is 2. So totally 4 values, because we can solve this quadratic equation, like when you solve this you get a quadratic, you get some values of x, and when you solve this you get another quadratic, you get some values of x, totally 4 values of x. So that's the reason we have got 4. And another thing is, it's a biquadratic equation, you can expect that the maximum number of roots can be 4. So that's the case, we have got 4 roots, and this is how you can solve a biquadratic equation. But basically the thing is, you need to make sure the coefficients are the same for the terms which add up to the degree of original degree, which is 4 here. So you need to make sure, then only this case works basically, or it becomes hard for us to solve. So the second thing that I wanted to tell is equation which can be reduced to linear, quadratic and biquadratic equation. So if there is a giant equation given to us, so how can we can like what's the way of approach to solve those problems? So there are n number of ways, like particular ways defined for particular things, like you need to make sure the basic set of rules, like the first rule and the second rule which I'm gonna explain, satisfy that or not for that equation, and if it is satisfying, then yes, we can use that. And so this is how you can deal this giant equation basically. So the first concept is, I'm gonna use a yeah, different ink, let it be a green now. Yeah, so it's an equation of the form x minus a into x minus b into x minus c into x minus d is equal to a. A is some constant, okay? This is how you do it, and there are some particular condition, that is a is less than b is less than c is less than d, and also b minus a is equal to c minus d. I think so it's d minus c. Yeah, b minus a is equal to d minus c. So this is what an important condition is. I don't say this is not important, like this is also important, and you need to make sure these both are you need to convert that into first. Like if I've given you in this case x minus 3 into x minus 7 into x minus 1 into x minus 4, so you need to make sure, like take the terms a is equal to the least one 1, and other one 3, c is equal to 4, and d is equal to 7. And now can you arrange these terms, like x minus 1 into x minus 3 into x minus 4 into x minus 7. Okay, so this makes the work easy for us. And also you need to make sure b minus a, which is equal equal to 2 and d minus c which is equal to 3, but these are not equal, so we cannot use this method. So only make sure, like when you put it in a ascending order, and also you need to make sure the difference between the terms like b minus a should be equal to d minus c, nor you can just ignore this method. But if it's the case, you can just follow this because it makes a problem easier to get solved. Like any math exam, preferably we use those methods which takes less time. So that's the reason. So I'll just put the condition once again. A is less than B is less than C is less than D, and also B minus A should be equal to D minus C. These are the conditions. So how can you do it is, you need to introduce a new variable. You need to introduce a variable that is y, which is nothing but x minus A plus x minus B plus x minus C plus x minus D. So this is I could have written in the, I'll just start from here just to avoid confusion. So you need to put a new variable, introduce a new variable which is x minus a plus x minus b, again random mistakes, so sorry for this, plus x minus b plus x minus c plus x minus d divided by 4. Okay, this is the new equation that you're gonna put, which is basically nothing but x of minus a plus b plus c plus d divided by 4. This is your new equation. Like I need to say new term, the y is equal to x minus of a plus b plus c plus d divided by 4. This is what you can introduce. So I can just put it in a problem and explain to you so that it gets a better, like it gives you a better idea for that. So if you just check it, it's 12x minus 1, 6x minus 1, 4x minus 1, 3x minus 1. You all know that the LCM of 3, 4, 6, 12 is 12, because that's the least common multiple that you can get. So you just divide it so that it comes in the form of in this way, right? So in the fashion where you find the x coefficient to be 1, like it becomes easier for us. In each term the coefficient of x is 1. It becomes easier for that as in if you solve in that. So just divide by 12, so it becomes in this way, x minus 1 into it's minus 1 by 12 into x minus here you need to divide by 12, so it becomes x by 2. No, I need to put make sure like this in the term of basically I need to make sure I'll just take the terms in this way. I'll just take 12 common, so it becomes x minus 1 by 12. Again, if I take 6 common, I can get x minus 1 by 6. I can take 4 common, I get x minus 1 by 4. I can take 3 common, I get x minus 1 by 3 is equal to 5 divided by 12 into 6 into 4 into 3, because these are the terms that we have taken common. So I don't feel I'm wrong here, like I've done the calculation process in the right way. Now another thing that we can notice is that 1 by 12 is less than 1 by 6 is less than 1 by 4 is less than 1 by 3. So we have got like a is less than b is less than c is less than d, and we also need to verify that b minus a is equal to d minus c. What is b minus a? It's 1 by 6 minus 1 by 12, which is nothing but 1 by 12, and another thing is 1 by 3 minus 1 by 4, again it's 1 by 12. So we are getting these to be equal, so we can just use the method that I have told you before. So that is you need to introduce a new variable which is x minus of a plus b plus c plus d divided by 4. So we have got all the terms required like a b c d. Just you can just put them there. So when you put them, we get 1 by 4 of 1 by 12 plus 1 by 6 plus 1 by 4 plus 1 by 3, isn't it? This is what we're going to get. So it's my x minus 1 by 4. You can just take the things common, like it's 12 LCM. So 1 plus 2 plus 3 plus 4. So 4 plus 3 plus 2 plus 1, which is 10. So x minus 5 by 24. 5 is equal to x minus 5 by 24. This is what you want to get. So x is equal to y plus 5 by 24, isn't it? We need to substitute the x because we are having the equation in x, isn't it? We have got an equation in x, so we need to substitute this y value that we have got. So what if I substitute this y value? What if I substitute the x value that we have got, if I substitute that, my equation turns out in this way. So it becomes y plus 3 by 24 in the very first term, and I get 1 plus 1 by 24, and the other term is y minus 1 by 24, and my other term is y minus 3 by 24, which is equal to 5 divided by 12 into 6 into 4 into 3, isn't it? This is what I gonna get. So if you just observe, it became very easy to us for us to solve. Y plus 1 by 24 into y minus 1 by 24 is nothing but y square minus 1 by 576, and here y plus 3 by 24 into y minus 3 by 24, it's again y square minus 9 by 576. So we have got it into a quadratic equation. Basically it's not quadratic, it's a biquadratic itself, but we got some quadratic terms in between which is easier to solve rather than a complete quadratic equation. So if I just go on to the next steps, I get y square minus y by 24 whole square. I'm not writing 576 for like easy recognition purpose. So the other thing is minus 3 by 24 whole square, which is equal to the constant, that is y by 12 into 6 into 4 into 3. So this is what we're gonna get. Now you can just find the the answers here. Y square minus 1 by 24 whole square, and this is this, and we can find the values from y from directly. We can just solve it directly, and we can tell that y square is equal to 49 divided by 24 square. And so we are getting one value of y to be 7 by 24, the other is minus 7 by 24. So this is y1 and this is y2. So these are the values of we are getting for y, and the corresponding roots of the second thing, we get the y3. You can assume that to be y3, it's minus 1 by 12, and the other is y4 is 1 by 12. So this is how you're gonna get. You can just substitute them and you can check them. You will be getting it in this fashion. So these are the roots of this biquadratic equation. This is how you can easily solve it. Like you have converted a big thing into a small thing, like a para-quadratic equations, like two sets of quadratic equations, and you have solved them for individually. That's how you can just make it, like it becomes easier for us to solve, because y square is equal to like you can just put the coefficients here. Like you can just put the for what values of this you are expecting this to be 0, and that is how you need to do. That's it, because you can just turn this thing to the left hand side and you can just equate them to the 0. So this is how you can just proceed. I hope you all understood this concept. So coming to the next concept, type 2. So what is type 2? Yeah, an equation of the form x minus a into x minus b into x minus c into x minus d, which is equal to ax square. So still now we were dealing with an equation which is only constant, which is only consisting of a constant a. So now it's time for ax square. Okay, this is ax square, and now again we have some preliminary conditions here, which is like your ab should be equal to cd. Okay, your ab should be equal to cd, and it can be like now the time for, like we can just substitute a variable like y is equal to x plus ab divided by x. Okay, so ab must be equal to cd, the same thing, a is less than b is less than c is less than d, and also you need to make sure that x plus ab divided by x is the variable that you're gonna substitute. So you just gonna solve for x and get it into the y form. Like you can just get a y value for some x and you will just substitute that here. So let us see with an example. I have taken example for every case so that it becomes easier for you people to understand the thing that I'm telling you. So this is the form x plus 2 into x plus 3 into x plus 4 into x plus 12 is equal to 4x square. And now we can just check it. Minus 2 into minus 12 is equal to minus 3 into minus 8, isn't it? Like we don't have any condition basically. Here we don't have, sorry, this is another form. Here we don't have anything like a is less than b is less than c is less than d. I'm sorry for that. Like I'm in a flow regarding that. So you just need to make sure, are there any terms like product of two terms is equal to product of another two terms? You just need to make sure. So I've got it basically. Minus 2 into minus 12 is equal to minus 3 into minus, like the first and the last term product is equal to the between two product, so they're being equal. So I can just assume some of them to be a and some of them to be b and the other to be c and d. So I can just write it in this way. So the thing is we have got this to be equal, so I can just transform this equation into x square plus 14x plus 24. Yeah, let me write it once again. Yeah, x square plus 14x plus 24 into x square plus 11x plus 24 is equal to 4x square. The thing is, because minus 2 into minus 12, I've just clubbed these two equation into this form and these two equation into this form. So now x is not you can just check it, like if you put x is equal to 0 here, we are not getting this to be 0, isn't it? If I put x is equal to 0, I'm getting 24, I'm getting 24 into 24, which is 576, which is not equal to 0. So x is 0 is not a solution. So you can just divide by x square, because you cannot divide by a number for which it's 0 actually. So I cannot put x is equal to 0 basically. So that's the reason I can just divide by x square on both sides. So if I divide that, so I can just get x plus 24 by x plus 14 into x plus 24 by x plus 11 is equal to 4. And we have assumed like x plus 24 by x, we can just assume that to be y. So it becomes y plus 14 into y plus 11 is equal to 4, isn't it? This is what we're gonna get. And this is quadratic equation, which is y square plus 25y plus 150 is equal to 0. So you are getting the one value of y to be minus 15, the other value of y to be 15. So this is how you need to solve. Like another value, I think it's minus 10. Yeah, one value is minus 15, other value is 10. So like these values are nothing but y is nothing but x plus 24 by x. So you can just put it the x plus 24 by x is equal to minus 15 and x plus 24 by x is equal to minus 10. So this is how you can just solve it. So you will get a quadratic equation here, you will get a quadratic equation here. So what are the values that you're gonna get? X1 is equal to minus 15 minus 1 by root 129 divided by 2, and the other value is minus 15 plus root 129 divided by 2. And if you solve here, you get x1 to be minus 6 and x2 to be minus 4. So these are the values that you're going to get. So instead, I have told you the first thing, like you can just put y is equal to x plus ab by x. You can just do that directly. You can just do that because we have got a, b, c, d. So we can just put that directly and solve. But where can we put that? Isn't it? Where can we put that value? Where can we substitute that x? We cannot just put that x in directly, right? So that's the reason I've done this form. First thing is I've got to know that a, b, c, d values, like a and b are this and c, d is this. So I've just written it in this form. And thing is, when I divided by x square, I've got to know like x plus 24 by x plus 24 by x is what I'm getting in both the things. So I just assume this to be y and I've got it in a quadratic. I've solved for it, and then again I've got just substituted this y as x plus 24 by x. So this is how you can solve. This is how you can make a big equation into shorter things and you can solve for it. So these are the some unknown techniques, like many people doesn't know that if AB is equal to CD is thing that you can observe that. So you can definitely solve this quadratic equation in a much simpler fashion, because you're even having 4x square here. So it becomes quite difficult for us to solve. So but using this method, like using this terminology that we have followed now, it becomes easier for us. So this is how you need to do it. I'm taking only one example per one problem because it's not a big thing that that cannot be explained. Like it can be explained with just an help of one problem itself. I believe that. So the type 3 is x minus a whole power 4 plus x minus b whole power 4 is equal to a. So this is another type of equation, and again we have some like we can just put the value of y here. We can just put the value of y here, x minus a plus x minus b divided by 2. So this is the value of a y that you're gonna substitute. So this is how you can deal the equations in this way. So I'll just take the help of the problem once again. So it's x minus 6 minus x whole power 4 plus 8 minus x whole power 4 is equal to 16. You can just assume that y directly, which is 6 minus x plus 8 minus x divided by 2, which is 14. So 7 minus x is equal to y. So x is nothing but 7 minus y. So just substitute this equation there. Okay, so it transforms it into this way: 6 minus of 7 minus y whole power 4 plus 8 minus of 7 minus y whole power 4 is equal to 16. So it's minus 1 plus y, so it's y minus 1 whole power 4, and here you get y plus 1, isn't it? This is a y plus 1 whole power 4 is equal to 16. So we have got it into this form, like y minus 1 whole power 4 plus y plus 1 whole power 4 is equal to 16. You can find various terms that's going to be cancelled, and finally you'll be reminded with very simple equation: y power 4 plus 6y square minus 7 is equal to 0. Again, you can just assume this y power 4 y square as some z, and you can solve that. Like you can get z square plus 6z minus 7 is equal to 0, where I assume that y square is z for me. So it transforms into this way, like z plus 7 into z minus 1 is equal to 0, which is nothing but y square plus 7 into y minus 1 is equal to 0. So you can just observe that any term, like any square of any term cannot be negative, isn't it? So y square cannot be minus 1, so y square like y square here, and y square can only be 1. Y square, like we have got this equation, right? Y square plus 7 into y square minus 1 is equal to 0. So y square cannot be minus 7, so this cannot have any root, but here we can find that y square can be 1. So y square can be 1 is a chance, and so the values that you're going to get is y1 is equal to minus 1 and y2 is equal to 1, because minus 1 whole square is also 1, 1 whole square is also 1. So we can get y1 to be minus 1, y2 to be 1. And what is y actually? It's basically 7 minus 6. So 7 minus x is equal to minus 1, 7 minus x is equal to 1. So what is the value of x you are getting? X you are getting as to be 8, and here you are getting x to be 6. So these are the two values that are possible. So I can just assume this to be x1 and this to be x2, x2, x1. Yeah. So this is how we can solve it. So once having a look at it, we can find, like, we feel that it's a big giant equation, but whatever be the values of a and b, anything, we don't need to care. We can just substitute the value of y to be a, like 6 minus x plus 8 minus x divided by 2. So you got it in a singular, like a simpler fashion, x is equal to 7 minus 1, and you're just substituting that, so it becomes it in a y minus 1 plus y minus y plus 1, which is very quite easy to solve, because many terms gets cancelled, cube terms gets cancelled, and many other constant, like many other things, terms gets cancelled. So that's the reason we can just easily solve this equation. So this is how we wind up this today's session. Like, I hope you all enjoyed this. This is a very good lecture in Wizard Concepts of Mathematics, which is like one of my favorites, like how to solve math quickly and easily, and also like remembering lot of facts is a best thing in math. Actually, it gives another level of enjoyment. So while solving math, like enjoying some things, just putting some random values and getting that answers, like it gives an thing, like it's an amazing feel. So this is why I actually wanted to include this concept. So I hope you all enjoyed this. So stay tuned for the next video, which is problem of the day. Thank you.